Welcome to Java Space. In this video, we are going to talk about a proxy. Everything that you need to know about a proxy. So we talk about proxy in a general sense, that is proxies outside Spring. Then we'll talk about proxies inside Spring. And then I will give you some practical demonstrations of usages of proxy. So as always, please don't forget to subscribe, because as you subscribe, you motivate me to continue doing what I'm doing. So what is a proxy? A proxy is a structural design pattern. A proxy is a class functioning as an interface to something else, and it could interface anything such as network connection, a large object in memory, a file, or some other resource that is expensive or impossible to duplicate. So a proxy is a wrapper or an agent object that is being used, or that the client will call. Then under the scene, under the hood, the call will be delegated to the real object. So you can think of a proxy as something that is front facing, that you will hit before you hit your desired target object. So as I said, a proxy is a structural pattern. So other patterns that we have that are structural, we have bridge, we have adapter. Adapter pattern, as a name suggests, you want to put together two things that are not compatible with each other. So when you want to charge your phone on the socket, you cannot directly put your charger on the socket. You need something first. That's something you put, which is an adapter. It's an adapter pattern. So even in programming, you have a situation like that, where you have two classes or two codes that needs to talk to each other, but they are not compatible to one another. So you create an adapter so they can be able to communicate. Then you have a decorator pattern, which obviously is used to give an object some additional features or behavior at runtime. A perfect example would be when you buy pizza. You start with a plain pizza. If you want to add more things, you can add some toppings, and you know that as you add toppings, your money increases. So that is another analogy or another use case of a decorator pattern. Then you have a facade, and a facade pattern is like an interface to some complex code. So I already talked about this facade pattern in my series on observability, where I talk about micrometer, and micrometer is a matrix facade. So you can visit that playlist if you want to learn more about that. So in summary, a proxy uses a surrogate object in place of another object. So you can think of it as a placeholder. The objective of a proxy object is to control creation of or access to the real object that it represents. So which means if you want to call the real object, your call will have to first pass through the proxy. So common usages of proxies. When you want to defer the cost of instantiation of an object, you can use a proxy. An example would be in the Spring context, when you have a singleton bean that depends on a request scoped bean or even a session scoped bean. When the application context starts, it creates all singleton beans, because we know that the application context creates beans eagerly. as opposed to the bean factory that creates beans on demand. So I have also a video where I talk about application context versus the bean factory. You can also visit that to learn about that. So the application context will create the beans at startup eagerly. So when it creates a singleton bean, it also finds, oh, the singleton bean depends on another bean, which is request scoped or which is session scoped. But these two beans are special in a sense that for it to be realized, there must be a request by the user. For a session scope to be realized, there must be a session by the user. So if those two do not exist, it is not possible to create those objects. I will demonstrate to you what happens when you try to do that. Spring will obviously throw an exception that the thread for that particular bean does not exist. Like it will tell you that that bean, it's thread scoped. It needs a thread to run. You will see that error as we go on. I hope I will not forget to demonstrate that to you. And yes, so you can also use proxies when you want to provide additional logic. So if let's say you are calling a method and you want to provide some additional logic either before you call that method or after you call that method, then proxies will help you to achieve that. So the common example would be when you want to do some caching. So let's say you have operations on the real object that are resource intensive in terms of, it could be performance wise or memory wise. Then you wanna do some caching so that you improve performance. Obviously, let's say you are retrieving large amounts of data, you wanna cache it. You can use a proxy to do that. Then let's say you want to do, you have some preconditions, you have some checks that needs to be to pass. You have some validations to do before executing a particular piece of code. A proxy can actually help you to achieve that. So proxying in Spring. So there are two types of proxies in Spring. We have a JDK dynamic proxy, then we have a CGLIB proxy. So let's start with the JDK dynamic proxy. A JDK dynamic proxy is not even a Spring concept. It's built into the JDK. So that means it's a Java concept. Spring is just borrowing it, So how does it how does this JDK dynamic proxy work? So if the target object to be proxied implements at least one interface, a JDK dynamic proxy is used. And all those interfaces that the target object implements, the proxy will implement all of them. Or you can say the proxy will proxy all of them. Then we have a CGLIB proxy. So CGLIB stands for Code Generation Library. So what is CGLIB? It is a byte instrumentation library used in many frameworks like Hibernate or Spring. So the byte code instrumentation allows manipulation or creating classes after compilation of a program, which is actually at runtime. So CGLIB is a common source class definition library, and it is repackaged into Spring, which means Spring will import it for you without you having to do it, because Spring actually uses that library. So if a target object does not implement any interfaces, it means you won't be able to have a JDK dynamic proxy or interface proxy. I forgot to mention JDK dynamic proxies are also called interface-based proxies. So if the target object does not implement any interface, the only option you have is to create a CGLIB proxy, which Spring will actually create it for you. So JDK dynamic proxy is the default proxy mode or mechanism that Spring will choose for you as a developer. So with CGLIB proxy, these are the following things you have to know before, or you could say, for CGLIB proxy to work, these are the following conditions. All right. At configuration class shouldn't be final. At bin method shouldn't be final. At bin method shouldn't be private. So because when you have at bin methods inside a configuration class, there are situations where you are going to have to have a proxy, which would mean the configuration class would need to be subclassed. So if that class is final, there is no way it will be subclassed. In fact, the application should not even run if you have your at configuration class final, or Spring should throw an exception of some sort. If you use an IDE, it will take it with some red line to tell you that what you're doing is wrong, because that configuration class will be subclassed. The add-bin method also, since it's going to be overridden, you cannot override a final method, so it shouldn't be, shouldn't be final. Then also private, it shouldn't be private, because then it means the subclass won't have access to it in any way. So these three things you must be aware of when you are dealing with proxies. Your add configuration class should not be final. Your add bin method should not be final. Your add bin method should not be private. So as of Spring 4, the constructor of a proxy object is not called twice anymore, since the CGLIB proxy instance is created through what we call Obgenesis. So Obgenesis is a library dedicated to bypass the constructor when creating an object. Only if your JVM does not allow for constructor bypassing, you might see double invocations and corresponding debug log entries from Spring's AOP support. You can get this from the Spring documentation website. So what are the usages of this code generation library, which is CGLIB? As I've mentioned, CGLIB is used, what libraries use this CGLIB? That's what I meant to say. Spring uses it, Hibernate uses it, EasyMock uses it, Mockito uses it, and many other libraries that I'm not aware of. So let's talk now about proxying in Spring AOP. So AOP proxy, proxying in Spring AOP. So AOP proxy is the object created by AOP to implement the aspect contracts. So this is what we said with Spring, proxying in Spring. We say Spring can use either JDK dynamic proxy or CGLIB proxy, but the default proxy mode that Spring uses is the JDK dynamic proxy. And for that default mode to be activated, the target object must implement one interface, at least one interface. But if it does not implement one interface, Spring will switch to CGLIB proxy, which is class-based proxy. So CGLIB proxies are created by subclassing the target object. So an interface is not needed in this case. So proxy now in Spring AOP. So activating proxies with aspect J. There is an annotation at enable aspect J auto proxy. So to add to activate that proxying with AOP, you will have to add this annotation. But with the recent versions of Spring, you no longer need to add this annotation. I actually tried it with Spring Boot. I saw that even if I do not add this annotation, I still get a proxy. You know, maybe I'm assuming that the latest versions of Spring, they do not you don't necessarily need to add these annotations because of auto configuration. They auto configure that for you. So to add behavior to existing objects, Spring uses a method called proxying, which implies creating an object that wraps around a target object. The add enable aspect J auto proxy annotation can also be used to set the type of proxies to be created. By default, we mentioned that Spring will use JDK dynamic proxy, also called interface proxies. But CGLIB proxies are requested by specifying the proxy target class attribute and setting its value to true inside with the enable aspect J auto proxy. So the CGLIB proxies are called subclass proxies because they extend the type of the target object. So this is how proxy work. You have a call to a method called foo, but before the call invokes this method called foo, it passes through a proxy object. Then the proxy object will delegate to the method of the original object, which is what I mentioned before. So basically this is how proxies work. So we have been talking about proxies and all their uses, but what is an alternative to proxy? So an alternative to proxies is what we call bytecode weaving. So when using bytecode weaving mechanism, you eliminate the need for proxies completely, the need for all those objects completely. Instead of you having behavior woven, around object or around a target object, you actually woven the behavior into existing code. So bytecode weaving approach takes a little more time to set up, and on top of that is complex. So when you decide to take this approach, you may need to set what we call a Java agent. You may need to modify your compilation process. You may need to use a different class loader. So as you can see, that bytecode weaving is complex to set up. So guys, please don't forget to subscribe. So proxy use cases. So now this is where we are going to see proxies in real coding. So what we're going to start with at bin, then use at scope, aspect, at transactional, then we talk about repositories, or in Spring they call them instant repositories. All right. So let's see this at bin, how proxies work with this at bin. So I have my code at here. So this is the code I've been using all around with my previous lectures. All right. So I have this configuration class here. You can just ignore these other configurations here. Then I have a class called engine, and it has a constructor that has this code. So I only have this code for us to trace what is happening. Then I have a class called Mercedes, which actually has an engine. I have Toyota, also has an engine. All right. So I'm going to show you how at bin and at configuration actually uses proxies. All right. So let's come here. So what we want to do here is we're going to define our classes. So I want to start with engine and make it a a bin. All right, so I have many options. I can actually either do this here and then return new engine and then annotate this with that bin. I can do it like this, or if I don't want to do it like this, I can come here and say at component. Whatever you want to do, it will work. So all right, so I prefer to do this one. All right, so I'm gonna remove this one here. All right, for this demonstration I need to use this one because I want you to see what I want to demonstrate. All right, let me remove this at component here. Okay, yeah, sorry guys. So what happened is that I don't normally rehearse my presentation, so even if I make mistakes, you have to pardon me. All right, so I have engine already, then I have Mercedes, and then I will return new Mercedes, and then here I annotate this with this. So you see that this requires this. So what I can do, I can call engine here method. That should work. So let me duplicate this code. So we have Toyota, we have Toyota, we have Toyota. All right. So as you can see what we have here, so what I'm gonna do is I'm gonna run this code. So since we are calling, so since the creation of these two bins actually need this bin, and we know that when we create this bin, we execute this in a constructor. So based on what we see here, this must be executed 2 times. So which means we must have this engine constructor printed twice in the console. All right, let's run this code. Look at that, it's printed only once, not twice. So what is happening here? All right, let's explain it. So because of this add configuration class and also this add bin, the call to this method does not follow Java semantics. So what happens is that this config object would be proxied, and the proxy will intercept this method, these bins here, creation of these bins. So which means that the first call will create this bin, but the second call, the proxy will first check whether this bin is already in the application context. If it finds it, it returns it. But if it does not find it, it will create it. That is why we have one log statement here. Whereas we were thinking that since we are calling it twice, it has to generate, it has to output 2 console messages. All right. So why is this even happening? Let's even go further. We know that Spring creates singleton bins by default. So by default, this bin is singleton. So which means that we see that we are requiring it here, and we are also requiring it here. Because it's singleton, we will only get 1 instance of it. So let's assume that we wanted to get multiple instances of this. So we could say at scope, and then here we say value equals to prototype. I think it's configurable bin factory dot scope prototype bin, which means now this bin will not be a singleton bin. We are making this bin to be a prototype bin, which means every time we request it, we get a new instance altogether. So let's run this piece of code. As you can see now, we get 2 instances because we requested it 2 times here, because now this bean is no longer a singleton bean. All right, so that is what I wanted to demonstrate. So now for us to know that the call to this is actually through a proxy, I'm going to run this code in, I'm going to put a breakpoint here. I'm going to run this code in debug mode so that we will see that that call here is through a proxy. Look at this. You see that this configuration class is a proxy, as we mentioned, and it's a CGLIB proxy. And why is it a CGLIB proxy? Because it does not implement any interface. So by default, Spring will use a CGLIB proxy. So already you can see that this is a proxy. All right. So I think that is it with regard to add bean. You saw what I wanted to demonstrate. Let's go back to the slide. All right, I was here. So a bean method, as you saw, can be static. So when we declare a bean method as static, Spring does not need to enclose does not need to initialize the class that is annotated with a configuration class, because it's static. And this behavior is convenient for bean post-processor classes. I will explain why it's convenient for them in the next slide. So since Java does not have overwriting of static methods, so they say, I forgot, there's a term that Java uses for static methods when you have the same static method in the subclass, or they say it hides it. It doesn't override it. It said it hides it. So CGLIB proxying does not work with static bean definitions. So there is a bean in Spring that is called property sources placeholder configure. And this bean, when you want to configure it manually, or not even manually, the way Spring has configured it, it is using a static method. And why does Spring, declare that bean like that? It is so that bean declaration is picked up when the context is created, earlier than the configuration classes, which are annotated with a configuration annotation, or even other component classes. Because everywhere you have add value and you want to inject properties inside that particular bean, which could come from property file or environment variables or anywhere, or maybe command line, then you want to inject those properties in your bean. The property sources placeholder configurer bean is the one responsible for helping you to inject those values there. So for it to help to inject those values, it must already exist, which means when you make it static, you are telling Spring to initialize it earlier than any configuration, earlier than any other bean, so that it will be ready to inject those properties in that particular bean where they are needed. So add scope. So add scope annotation is one annotation that you can actually use to decide what proxying you want to achieve. All right. So let's look at that. So we have prototype scope beans, we have session scoped beans, we have request scope beans, application scope bean, WebSocket. All right. So all of these except this one, they are applicable in web aware application context, or you can say web application context. But for this prototype is for standalone application context, like annotation config application context, or bin factory. All right, so now let's look at proxying using this at scope annotation. I already have it here in the bin definition. So I'm just going to comment out this line here. So what I'm going to do is I'm going to run this code in debug mode. So what I want us to do is I am injecting this random service. I'm injecting it in the bootstrap class here. So I have put a breakpoint here. So we want to see what type is this random service. Okay, let's run it. Okay, so let's see. Random service. Okay, let it go. All right. So as you can see, random service is just a bin. It's not a proxy. So the way you check a bin is a proxy, you look at how it's defined. You look at here. You can see it says employee service $$ Spring CGLIB. So this tells me that this is a proxy. It's not actual object that I had created. It's a proxy that will delegate to the actual target object. So as you can see, this random service is not a proxy. So we can make it a proxy. All right, let's make it a proxy. So let's just uncomment these 2 lines. Then we are using it scope. So we are saying that random service is a prototype scope bin, which means that every request of this bin you will get a new instance. And then we are saying the proxy mode is target class. All right. So let's run this code. All right. So let's check now. Our random service, as you can see, it's no longer just a bin, it's a proxy from here. So we can even see here, it's a CGLIB proxy. Why is it a CGLIB proxy? It's a CGLIB proxy because we defined it to be a class-based proxy. So let's say we want to put interface-based proxies. This is how you will select it. Let's run this code without running it in debug mode. As you can see, already this is an error. Why is it an error? Because random service does not implement any interface. So Spring is unable to create an interface-based proxy. Spring is unable to create a JDK dynamic proxy. All right, so this will not work. I remember that I promised to show you this. So as you can see, this is an error. What type of error is this? Okay, we don't even see an exception. I thought I was going to see the exception that was thrown. Okay. And in any case, we see that we are unable to create this because doesn't implement an interface. So this is it. So if we do not want to do this thing here, we can take this code out of here and delete that code. Then we can come and say at component, and we can place it here. We are gonna obtain the same behavior. As you can see, it's a CGLIB proxy. And if we remove this piece of proxy where we are specifying the proxy mode, we should go back to the JDK. Then we should go back to just a bin that is not proxied. All right. So this is how we see a proxy gets generated. So I also promised to show you that a request scoped bin and a session scoped bin, they require a session of the user to exist before they can be realized, or they require a request. All right, let's demonstrate that. So now we have this random service here. We want to make this okay, let's bring back the proxy mode. We want to make this a request scope. So as you can see, we do not have a request. All right, so I believe it's in is it web aware something? Web aware web. Okay, let me say request scope. Okay, let me just control click to see. Okay, I was actually correct. Web application context, just that I don't trust myself. So if we say web application context dot request scope request. All right, so what we are saying, this random service needs a user request to be realized. But when Sprint starts up, so if we do this, I'm going to show you something. Let's go to our Bootstrap application. So what I want to do is I'm going to comment out this line and also comment it out here. So what I'm going to do here is, okay, let me close this. I'm going to say, okay, let me just say sysout dot out so that I can have a breakpoint. So if we run this class, I want you to observe what happens if we run this class. As you can see, the class runs fine because we are not requesting this bean in our standalone application, and there is no request for it. All right, so let's do this. So this is a request scope bean. Let's run this application again. I'm gonna run this application. Look at now, we have an error. And then look at the error. It says no thread bound request found, which means you cannot inject this bean the way you are injecting, because this is not a web request or a web aware request, that it needs a thread bound request. Yeah, it doesn't exist. Only when the user makes a request, or if it was a session scoped bean, only when the session get created will this bean be realized. Yeah, so this is what I wanted to show you. I also talked about showing you this in code. So this is not allowed. You cannot do this. All right, so let's go back. But you can actually use this bean here. Okay, let me show you. Let's leave it. So web application context dot scope request. We are injecting it in this class. It does not allow that. So let's inject it somewhere else, and you will see that it will work. And where do we want to inject it? In a web or thread bound request, or in a thread bound request, or in that context. All right, so let's put it here. So if we put it here, random service, and then we call which method? Okay, let me just put it here. So I'm gonna say random service.print. All right, let's see what random service print. Okay, it just say employee amount. All right, which is random. So now we're gonna run this code. It should run fine. So let me open this postman. So this postman, I'm going to call that REST method. I believe this method will go there. All right, so we see that we got all employees, and this comes from a database. So let's come and look on our console. All All right, so let me do this quickly. Let me deactivate this. Let me say false here, so that we do not see that hibernate code generated. So let's run this code again. All right. So this is the code that the print method. This is what it actually printed. So let's do this again. See, every time we get a new instance of employee of random service, sorry, and we see that this gives us a new value. Why are we getting a new instance? Is because this random service is request scoped, which means for each request we get a new instance to serve that particular request. So we can also make this a session scoped, but obviously a session scoped and request scope, they work the same. All right, so we will not demonstrate that. Okay, I guess I'm done with scope and proxies. We saw that we can use a proxy mode, which specifies whether a component should be configured as a scope proxy, and if so, whether the proxy should be interface based or subclass based. So now let's look at aspect, so that you see that even with aspect oriented programming, that they use proxies for them to actually add that additional behavior at runtime. Okay, let's prove that. So we have this aspect, annotated with at aspect, then we have at component. All right, then this is the method that we are intercepting, get list, and as you can see, we are using before advice. So I talk about advices and AOP. There is a series I have created dedicated on AOP. If you want to learn about AOP, you can actually go to that series. So at the end, I'm going to put all these links in the video description for this particular session. All right, so we are intercepting the get list of employee service with AOP. So then what that means is that this employee service, when we inject it, we are not going to get the employee service. We are going to get a proxy. Because of this, we have actually intercepted this. So for that to happen, we will have to go via a proxy which will intercept this method. Okay, let's see that. So I'm going to run this code again in debug mode. We already have employee service here. All right, so let me go back to the previous code that I had, and then I'm going to put a breakpoint here. So I want you to see that this employee service bin is not just a bin, it's a proxy. Okay, let's run it in debug mode. All right, so now let's see that the employee service is a proxy. Employee service, as you can see, is a proxy, and it's a CGLIB proxy. All right, why is it a proxy? Because of AOP, because of that advice we are adding for that method in this particular class, and we see that it uses CGLIB proxy because let me show you, because employee service does not implement any interface, as you can see. It's just a class. And then this is the error that we had with this request scoped bin. As you can see, method through scope not active exception. Yes, this is the exception I was looking for when I was showing you that error. It's a scope not active, which will be active in a request. Okay, so what I want to do now is I'm gonna remove this because we don't need it. Then I'm gonna say employee service. Let me stop this code. Dot get all list. All right, so we saw that this employee service Okay, let me run it again so that I show you that employee service is a CGLIB proxy. All right. Okay, so I want to show you that by not advising this get list method of the employee service, this will no longer be a proxy. Okay, so what do we want to do? Let me comment out this method. All right, now let's run this code again. We are no longer advising that. As you can see, employee service is no longer a proxy because it's not advised. It's just a normal a bean. All right, it's just a normal bean. Okay. Let's uncomment this code again to make it a proxy. So what I want us to do is I want us to I have not demonstrated JDK dynamic proxies. So let me create an implementation of this. Implement, and what I'm gonna do is this. I'm gonna remove this here. This was gonna be an interface, and then this interface will contain this method, and then this is just a declaration. Okay, let's remove all this code. Then in here, what we want to do, we want to implement employee service, and obviously this is an add override. All right, so now we have a service. Okay, so let's run this, man. Okay, let's run this and see. This is no longer a class. It's still a CGLIB proxy. I want this to be a JDK dynamic proxy. Okay, so let me do this. I don't know why it's doing that, so I'm gonna say, let me put this class here. So it's still a CGLIB proxy. So what I'm expecting to see is it must be a JDK dynamic proxy, because the method that we are advising is in a class that implements an interface. This is what I'm expecting. Okay, as I said, I don't normally rehearse these things so I will have to go and find out why this is happening. Dynamic advised interceptor. Okay, so I'm not sure why this is doing this. Is it? Okay, it's fine. I'm gonna skip that section. Let me see what we have next. Okay. I will have to. I will leave some. I will make some follow-up video about this, and then I will present it. It's fine. So let's proceed to add transactional annotation. All right. So the add transactional annotation also entails, also will make your class to be a proxy. All right, so on top of add service here, what I want us to do is I want us to add a transactional. Okay, so what I want to do is let us remove this so that it does not get proxied by an aspect. So what we want to do is here, okay, let's just run it like this without that, and then we see that it goes back to just being a bean. You see, it's just a bean. All right, so now I want to add some annotation, which is a transactional, to make this to imply a proxy generation for it. So from latest version of Spring, I heard that you can actually do this, which will imply that classes that implement this interface are transactional. So let's test that. Look at that. So as you can see, you have this as a proxy, this employee service. All right, so okay, let me do this. Let me not put it from the interface. Let's put it here. Let's put it from the implementation class. You see that you still get the same behavior. So I'm going to put it here. Let's run this class again. You get a proxy. So you see, this is still a proxy, and it's a CGLIB Spring CGLIB proxy. Okay. Okay, that's fine. And if we remove it, we will get a normal B. So we know that a transactional annotation will create some code for you. In my AOP series, I explain it, that it implements a round advice. It begins a transaction, then you have code, then it ends a transaction. All right. So that is it in terms of a transactional annotation. Then we have a repository, sorry, not a repository, a repository interface, which is called instant repository in Spring. All right, so what we are going to do here is, I'm going to show you that also at repository, sorry, the instant repositories, when you use repository Spring Data repositories, you get a proxy also. Repo.findAll. I'm just going to call this method here. All right. So if we call this method here, this repo, as you can see, it's just an interface, no implementation. But Spring will give us an implementation at runtime. All right. Let's run this in debug mode and see that proxy that we get. As you can see, this repo is a proxy, and it's a JDK dynamic proxy. As you can see, JDK dynamic proxy, and this is simple JPA repository that will be implemented for you. All right. So as you can see, this is a proxy also that you get. All right. So that's how repositories the repositories work. Okay, so we are done with code implementation. As I said, I will make a follow-up video where I demonstrate the other part that I was not understanding why it was happening. So interface-based proxies. So there is a note that I want to mention, is that the advantage here of interface-based proxies is that interfaces do not have non-public methods that might escape proxy. Because with class-based proxies, you're proxying a class, which can have private methods or whatever. But now, starting with Java 8, interfaces can contain private and default methods for obvious reasons related to access modifier, private methods. Obviously, they are not proxied. That is why we saw in one of the rules I explained that add configuration class cannot be final, add bin method cannot be final, nor can it be private. So default methods are methods that are declared in an interface, and that method they were created for backward compatibility in JDK 8. So if you declare a default method in an interface, you don't need an implementation for it. All right. So the classes implementing that interface will not need to override that method. it's inherited by those classes, and those default methods are proxied. But the private ones that are in the interface, they are not proxied. Alright, so guys, please don't forget to subscribe and motivate me. This video was long. It needed to be long because I needed to talk about quite a number of things. So if you have learned something from this video, please don't forget to subscribe. Thank you, and I will see you in the next videos or in the next lecture.